start. So, so I just set the stage. So I've been in this field for about 21 years. I've been in 13 different industries. So like Dick says, it touches everything. And it doesn't matter where you go, and this is just my experience, everybody seems to fall into the same rut, and we all see the same gaps. So what I want to just run through today is to show you what we're actually trying to achieve differently to bridge that gap between the project itself and operations. So one of the biggest areas that I see is today we have EPCs that are trying to completely manage the product that we're trying to build. But what's happening is we don't have any integrated strategies. That's one of the biggest areas that I see that's a fault. And so what the owner-operator doesn't understand is, excuse me, what happens is the owner-operators are not engaged early enough in the project. Then we have an issue with maintaining the flow of information, and then we don't even get the concurrent engineering correctly. So what do we need to do to fix this? Did you get the picture? We got it, okay, good. We don't want to take a business as usual approach anymore. This is not working for us. We don't have enough people on the planet anymore. We don't have the right schedules in place. We have overages and higher costs. Our concurrent engineering isn't working, whether it's a capital project or even running something and maintaining in operations. Today we can't afford to have poorly implemented systems, because that's really what we also have today. And we accept unacceptable information going forward. And the biggest piece I find is we have a lack of governance. So therefore we don't have a strong backbone for what we actually want to create. So our issues today is we have issues with handovers. Like Dick was saying, it's multiple phases. We don't just, years ago, I remember this even, I'm from Northern Canada, and I'm part of the oil sands group. And years ago, we would just do one huge handover, and that was it, right? We'd have paper and paper and paper. And it just wasn't sufficient to run the plant that way. So what we started doing is doing phased approach. Projects, again, aren't supported with replication that we're trying to achieve. And individuals and disciplines are not seizing the opportunity that the owner-operators is handing to them. The last point here is we have in the next 10 years, I can't speak for the US, but in Canada, we have a huge number of projects that are going to be built, engineered, and turned over. And we're talking in the billions. So this is the world I live in. And it's not just about information management. It's not about a piece of paper anymore. It's about systems, it's about technology, and it's all three. So one of the things I find really interesting when I work for different companies, whether it's BP or Exxon or Chevron, ConocoPhillips, Shell, everybody has this pie in their organization. And what I find interesting about this circle with the pie pieces is that I can go over to one company and they'll have too many people. They'll have a lot of training, and that's great, but they don't have a backbone of processes to keep that running as an organization. Some companies, I've seen as much as 2,700 applications in a small company, if you can believe it. And it's what it is everybody has their own idea of how they want to do things, and then we end up with 2,700 applications, when really we could probably get by with even 500, right? I'm divesting a project right now that's about $2 billion, and we have 55 technology pieces alone. So that gives you an idea of what we deal with every day. So when I go into these organizations and clean up and help them achieve a better system for their life cycle of their projects, one of the things that I try to do, just a second, is to create the most perfect circle that I can for that organization. So how do we do this? Well, it has to actually start at the top. It has to start with policies. We have to create a policy within our company. As you know, every company I go to Imperial Oil. They have a policy that they drive their company by. They have safety, they have rules. They make sure they have a vision and intent. Now through that we create awareness, then we have requirements and obligations as an organization, and as you can see, the detail gets greater and greater. And this is where, if you look at the bottom, we're looking at implementing and training people and processes so that we realize our full strategic intent as an organization. This in turn actually reduces risk. So safety for me is one of the biggest things that drives me to go to work every day for information, is to make sure we have good asset integrity for operations. We reduce the risk and reduce safety issues. And then as Dick was talking about earlier, it starts with engineering. And one of the other things that we're looking at is targeting reduction of rework between phases and making sure that we actually have in-house tools that we use that create good quality for engineering information. And therefore, our economics are changing as well. So what's our target? What's our solution? We want to address, excuse me, one of the things I think as all the organizations today run in little silos. We have all this technology, we have all this experience, but we haven't figured out how to get them all to talk yet. So if we could come up with a standardized set of tools from the owner-operator to get the EPCs to feed into that system and use workflows and web-based systems like the cloud and everything like Shell's doing right now. They've come up with the cloud, and they want their EPCs to work in the cloud. I don't know if everybody's familiar with Shell's DEPs, right? We want everybody to start using those if you're in the Shell environment, right? If you're with Exxon, we have a different set of standards to use. So what we want to do is create a portal for everybody to go in, use standardized tools, methodologies, specifications, so that we can come up with something really great. So I was recently part of this team for the last few years down in the Gulf of Mexico in Louisiana. We have been using this technology for almost 20 years, but nobody knows about it. They have been creating and building platforms in the Gulf of Mexico that, you're 800 by 800, you don't have a lot of room for mistakes, and you're trying to keep this thing floating, right? So the idea of what I was trying to show you here is we've taken this idea and we've brought it into Northern Canada because we're trying to create a different modularization method to get things done a little faster. We have weather issues. We have 3 feet of snow right now. We have short seasons to build, and construction times are often delayed. So we're trying to come up with different methods to create the asset that we're looking to build. This picture, I wanted to show you this because this actually, everything that you saw in that, the point of that video was the engineering team in Louisiana, like in New Orleans, for example, their changes that are coming out of the spool yards, like in the fabrication yards in Corpus Christi, are actually getting brought back and put into these databases and regenerated within 24 hours. And so it talks back and forth. So we're actually almost doing it real time. And we're doing things like dimensional control, RFID tagging, all of these methods and systems that we're using actually come from all of these buckets. This is the way, I drew it this way because this is how I see the world. You guys might find this really odd, but a lot of people think it's a lot. But it comes from everything from the owner-operator systems to how we move things through secure FTP encrypted sites, and then what we talk about produced from the engineering and management side, whether we're using flat files with AutoCAD, we're using SMARTPLANT to generate a smaller type of a model, or we're going with SPP and ID. The other thing from that video that we've now changed is we've actually integrated, and we're doing 5 dimensions now. So we're actually taking SMARTPLANT materials, and that's the other dimension that we're actually interfacing to create real-time engineering information. So that's what really that centerpiece is. It's how we integrate the 3D model back with the P&IDs into SAP. We manage it through our cost, and then any logistics and even the process data. It all gets integrated through a web portal. This is just an example of something we've done in the last year in another LNG project up in Canada, where these boxes are all just showing all of the Intergraph, sorry Aviva, all the Intergraph product that we're using for this particular project. We're also, in that video, we were using Aviva Net to actually be able to look and manage our construction modules and the actual methods that we're using for construction on the project. Again, owner-operator with the EPC, we work together as an integrated approach, team approach, to make sure that our data points all talk to each other on a live, ongoing basis. And we take that right down into the architecture of everything from a field device all the way through our process control, right into our corporate office. One of the things Dick was talking about earlier was handover. How do we make sure we hand over at the right time for the right reasons? And make sure we have multiple handovers or continuous handover. So we tend to want to set up something between, if you look on the bottom, it has project all the way to operations and maintenance and how that handover works. If we measure 7 times and cut once, you can actually get a more effective handover into operations at the right time, so you're ready for operations. One of the things I just wanted to show you is I'm not sure if everybody here is familiar with the stage gate process that we use on capital projects. We have to have what's called gates. These are our checks and balances that we go through on a capital project to ensure that we're doing the right thing for the right reasons. And most of it also is so that we can get money to keep going on the project. And the world I work in is usually around $10 to $40 billion per project. So it's very important that we make sure that we have all of these business units engaged early on in the project to make sure they all have due diligence when we need them. So for example, gate 2 and gate 3 are very, very important points of the project, because that's where we actually want to make sure that we've got everybody engaged, like operations, so that we're not having to do rework later. Again, talking about the project life cycle, it doesn't just stop and start with engineering. We work integrated right with fabrication, shipping, making sure everything gets to site. If this is integrated within the operations team, within the owner-operator itself, this actually works a lot smoother than having a third-party company sub into an EPC and then do our process that way. One of the things that I think is critical as well when we talk about continuous submission for data or documentation, it's making sure that it's continuous, it's electronic, and then we have some flows to it. And it all actually comes back to the tag, and it comes back to, which is the asset itself. So again, when we talk about CAPEX to OPEX, we have continuous submittal and continuous turnover. I've been involved in a project where, this is probably back in 2008, and came up with an idea. We're actually building one plant and replicating that plant next door. So we wanted to take the engineering information from that system and duplicate it to the next engineering team at a certain time. So it really had to do with going from a phase 1 or to a phase 1 to phase 2 approach. We've saved about $250 million cutting over our information the right way and creating a different type of tagging system that actually helped manage the asset a lot more intelligently. So how do we do that? We want to interface. So this is one of my favorite slides I like to show companies that when we talk about pure integration. So I'm the owner-operator, so I'm in the middle bucket. It doesn't matter what I'm building, if I'm going to Siemens to build a cogen or I'm going to NEM to build a Herzig, it's how this is all fed back into the EPC at a continuous, and where this is daily movement of information. Some of it can be weekly, but mostly it's daily. And then what we do is we do the validation. So the blue buckets are all the different companies that we would deal with on a project. The gray buckets are how we actually interface and talk back and forth. Those validations, again, are done on a daily basis. And if you could see, for example, like Emerson, they may be the MAC in this situation, but Spartex can actually feed their controls all of their product back that way, and then it comes to us. The other piece to this is we can have multiple cities for the same company. So I could have my field infrastructure out of Houston and my civil works out of Calgary, and it's actually the same company. But again, they're all feeding into the same method. So again, going back to the video, we have to make sure that we create a data warehouse. This is as simple as it looks. They're all big buckets. They feed back into a main system, and it all functions back to the asset. The asset has to be the starting point and the end point of what we want to do to achieve real-time data. So this is just some of the data tool sets that we use. We have a master equipment list, which has all these types of requirements, right down to shipping. We use a web interface for our master equipment list as well when we talk about our tags and our components. Whether we're shipping a huge module or we're shipping a loose item, like 1,500 transmitters, we want to make sure that we can track and trace all of that. So this type of system actually does do that. All the vendor information, how we talk to our vendors. One of the things I did in the last year was, on another project, was create an automated data sheet. So everything was, it started with the mechanical engineers. It took a lot of time actually to do this, but the point of it was when we send the data sheet out to the vendors, everything would be grayed out except what we wanted them to populate. We bring it back, push it up into the system, and it literally took minutes. And it was a one-to-one asset instead of many-to-one, which what we often see. We do a lot of validation. So again, going back to that video, it all starts with this. It starts with intelligent databases that talk and pull and push information on an ongoing basis. We can do exports from our 3D models. This is just an example of an export of what came out of a 3D model that gets pushed into the SMARTPLANT P&ID system, and then we can validate. We can do scorecarding. These are MCCs that we're actually putting into the field and commissioning, and we can actually scorecard and see where we're at. And we use technology to just make sure our commissioning is done at the right time. So how do we want to achieve all of this? Well, so a lot of companies are already starting to use the cloud environment. And what's really, I think, beneficial to this is that we're all creating the same information, we're pushing it to the same platform, we're validating it the same way, and we're using the same rules. So my biggest, one of the biggest things that I push in the industry, in my field, is making sure that everybody's using the same procedures, the same standards, the same processes. And the last part I just wanted to show is, so using all these tools that we use in integration, we can actually use them for as-building. We can use laser scanning, for example. So I want to retrofit this pipe in. I can set up my scanner locations, and then I can actually see where my drops are going to be and where my tie-in points are going to happen. Having RFIs like this come out of the field, again, creates real-time data for us, and it's quite beneficial, right? And that's where the operations side of maintenance things come into play. And then again, one of the other things, I'm from Northern Canada. I'm just, for an example, we're designing a plant. It's so far northern BC that, our actual engineering company was down in Calgary. So the difference between the two is, well, it's an all-day flight basically to get there. So if we can create remote control rooms on cloud environments, again, we can help with safety, flights. We don't have, the expense just goes away quite a bit. One of the other things too, going back to that other video, they have in New Orleans in One Shell Square, they have what's called a bridge, and they have 6 control rooms up there for everything that's in the Gulf that they're trying to control at that moment. And what that does is they can take a lot of the, for example, alarm management effort and things like that off of the platform in the Gulf, and they can just handle it right in the tower and let the gentlemen that are on the platform and the ladies just manage the actual rig itself. So that's another example of remote controls. That's it.